In this reaction, we have a boron, right, capturing a slow neutron, then splits into the lithium and alpha particle, also giving out a gamma particle in the process. We are given information about the binding energy of the three nuclides plus, right. We are also told that the total Ke of the products, right, is 2.31 MeV, supposed to find energy of the gamma. So let's write out the equation first before we try to solve. So we have 105B plus 10N turns into 73 Li plus 42He. Okay, and of course, right here there's a gamma. So before the reaction, right, these two guys are actually no Ke. Why there? Because, right, this boron is just sitting around, not doing anything, and it happened to capture a slow neutron. So slow neutron means this guy K is 0, and the boron is just sitting around, so this guy K is also 0. Okay, so both of them, right, have a total Ke of 0. Therefore, right, you see, in this reaction, energy is given out. This energy is given out, right, in terms of what? In terms of the gain in the Ke of the nuclides. Okay, so these two guys, right, gain how much Ke? 2.31 MeV. Then, right, this one also have a certain amount of energy which is unknown. Okay, if you were to figure out the frequency instead, then you'll use this formula. In this question, we are just supposed to know the E. Alright, so these two plus together, right, will be the energy released in the reaction. Okay, and in this reaction, we are given information about binding energy. So how do you go about thinking about the binding energy? Okay, is, right, we are imagining a hypothetical step whereby, right, we turn the reactants into the constituent nucleons. Okay, that means, right, we tear apart the boron, okay, into the nucleons. So in this process, right, we have to supply how much? We have to supply energy, right, equivalent to 64.94 MeV, right. You have to supply this amount. Then, right, when you have this and you use it to make the lithium and the helium, then, right, you will have how much being released? Well, it will be 28.48 plus the 39.25. I think this together gives us 67.73. Okay, yeah, so the difference, right, in these two, you see here you have to supply this amount, and later on you have 67.73 MeV release. So net, right, is gives you a energy release, right, of the difference, which is 2.79 MeV. Okay, so this 2.79, right, partially it goes to the 2.31, the remaining goes to this guy. So you do a simple math, the gamma particle must have energy of 0.48, and that's A.